and this will be our first class on probability. Before you continue watching, make sure to subscribe and like. Our topics today are going to be probability, independent events, and finally casework. So our first topic today is probability, and probability is basically the ratio of favorable outcomes to the total number of outcomes. It's basically saying what the chance is to get what we want. So some examples is tossing a coin. Like the probability of getting heads is 1/2 because there's only heads and tails. And then there's throwing dice. The probability of getting any number on a fair 6-sided dice is 1/6. So there's an equal probability of getting heads or tails, or 1, 2, 3, 4, 5, or 6 on a dice. And some terms you might want to know. Our experiment is basically trying out probability by performing an action like tossing a coin or throwing some dice and seeing what you get. Sample space is the total or like any kind of outcome you can get. For a coin, it's heads or tails. For a dice, it's basically all the numbers 1 through 6. And then we have event. It's basically what we get. Like an event for a coin is tails or heads, and an event for a dice is any of the numbers. So our next topic is going to be independent events. So let's first define some terms. So two events are independent if the result of the first has no effect on the second. For example, I can be like, let's throw this dice, and whatever I get, the probability of getting, let's say, a 3 on the dice and getting heads on a dime. They really don't affect each other unless there's some weird science thing that says it does, but there isn't yet. So they're independent. Now moving on to dependent, two events are dependent if the result of the first has an effect on the second. So Christmas was recent. So an example of that is, let's say you and your sibling want to pick presents, and because your parents are sometimes mean, they let your sibling go first for picking a present. And so they picked the biggest present, and you wanted that, or you wanted a big present. So your chances of getting a nice present has lowered since your sibling has already chosen one. And those two events are dependent of each other. Another example is, I have 4 coins in my pocket. I'm broke right now. So I have 2 pennies and 2 dimes. The probability of getting 1 dime is equivalent to the probability of getting a penny. So let's say I take a dime. Then the probability of getting a dime or penny has changed because there are less coins to choose from or less things that I want. So that's dependent. And basically there's a formula if two events are independent. It's let's say we have an event A. That's P of A, the probability of A. And we have another event, probability of B. And you want the probability of both to happen, like rolling a 3 on the dice and getting a heads on a dime. P of A might be the 3 on the dice, and P of B might be getting a heads on a dime. So the probability of having them both, we multiply them together. So let's try doing that real quick. The probability of rolling a 3 on your dice is 1/6 because the thing we want is a 3, which is one thing, and there are 6 total things that we can get. The probability of getting a heads on a dime is 1/2 because we can either get heads or tails. So we only want one thing, 1/2. So the probability of getting a heads on the dime, not the dice, and getting the 3 on the dice is 1/6 because 1/3 times 1/2, or 1/6 times 1/2 is 1/12. So our base 1/12, our probability of having that is 1/12, not 1/3. So sorry about that. And basically, replacement. If you're replacing the event, then it is independent. For example, if your sibling decides to be weird and puts a present back, it's independent. Or if I decide to put the dime back after I chose it, it's independent. But if I don't put it back and that older sibling's meanie, then that's dependent. Do you think math is hard? Do you think that every counting every single thing is hard? Do you want an easier solution? If you answered yes to any of these questions, well, casework is a thing for you. It's a much easier solution, but one thing is, you might want to stay organized. Casework. So the most important thing about casework, which is super, super important, or else you completely lose the point of casework, which is be organized. Like, you have to be organized or else you're going to lose where you are, and casework is going to die, and it's not going to be helpful at all. You're going to end up with this huge mess of numbers, and you're going to be like, what am I doing? That's why, be organized. So, what is the probability that the third roll is greater than the sum of two previous rolls if you're rolling a dice? So let's get some dice. So we have 3 dice, right? Meaning in each dice, we have 3 things that we can roll. For example, we can roll 1, 2, 3, 4, 5, or 6 for the first one, for the second one, and for the third one. So I have 3 dice here. And basically, what it's asking is, let's say my 2 red ones are my first 2, and this clear one is the third. It's basically asking if the sum of these 2 is less than this. And this one didn't really work out because the 2 red ones are 5 and 3, which sum to be 8, and the clear one is 1. So that's what we don't want. So let's try doing this. So we know we have a total of 216 possible combinations. And let's do casework. And our cases are going to be if third roll is a 6, the third roll is a 5, the third roll is a 4, and the third roll is a 3. So starting with 6, we want our sums of our 2 dice to be lower than 6. And we have 1 and 1, 1 and 2, 1 and 3, 1 and 4, 2 and 1, 2 and 2, 2 and 3, 3 and 1, 3 and 2, and 4 and 1, which make 10 favorable outcomes. So those are 10 examples. But that's not all, because those are only when the third roll is a 6. Now we have that the third roll is a 5. We have these 6 ones. And basically, my organization in this kind of casework is I have my third roll and I have a table here. You guys can do anything you want as long as it's still organized and you can understand your own things. So 5, we have 6. For 4, we have 3. And 3, we have 1. And so our favorable is going to be all these total cases added up. We have 10 plus 6, which is 16, plus 3 is 19, plus 1 is 20. Meaning we have 20 favorable things. And the basic formula of probability is favorable over total, so 20 over 216, which simplifies to 5 over 54.
Hi, my name is Siddhi, and I'm going to be showing you how to do some problems with probability. What is the probability that a randomly drawn positive factor of 60 is less than 7? So first off, we need to find how many positive factors of 60 are there. So the first thing you need to do that is prime factorize 60. So 2 times 30, 3 times 10, 2 times 5. So this equals 2. Then what we're going to do is use the formula to find the number of divisors. So for this formula, you have to you have to add 1 to the number of exponents there are. So 2 plus 1 times the number of exponents in 3 is 1 plus 1, and same here. So this is going to equal 12. Then what you have to do is find how many positive factors are less than 7 in 60. So for that, the positive factors are 1, 2, 3, 4, 5, and 6. So as you can see, there are 6 positive factors less than 7 for 60. So you have to put 6 over the total number of positive factors, which is 12, and the probability that you get is 1/2. Okay, that's it. A teacher keeps a jar full of different flavored jelly beans on her desk and hands them out randomly to her class. But one particularly picky student likes the licorice flavored ones. If the jar has 50 beans in all, 15 licorice, 10 cherries, 20 watermelons, and 5 blueberries, what is the probability that the first 3 jelly beans picked out are licorice flavored? So in order to find the probability of the first 3 licorice jelly beans, you have to put the total number of licorice over the total number of jelly beans, which would be 15 over 50. Then you have to multiply it by 14 out of 49. And that is because when you take one jelly bean out, you have to subtract 1 from the total number and the number of licorice because you're not replacing it. So you'll multiply it by 14 over 49. And then you have to do it one more time because we are finding the probability for 3 jelly beans. When this is simplified, you will get 1 over 10 times 1 over 7 times 13 over 8. When this is multiplied all together, you will get a total of 13 over 560. This is your probability. A basket contains a total of 24 balls of yarn. 1/3 are white, 1/4 are red, 1/6 are blue, and the rest are black. What is the probability if you reach into the basket and pull out either red or black? So the first step to solving this problem is finding the number of white, red, blue, and black yarns. So to find the number of white, you'll have to multiply 1/3 times the total number, which is 24, which equals 8. So you'll have 8 white balls of yarn. You do the same for red. 1/4 times 24, which is 6. And for blue, 1/6 times 24 equals 4. And for black, they don't give us the fraction. So in order to find black, we have to multiply all of these together and subtract it from 24. So when you add all these together, you're going to get 18. And when you subtract that from 24, you will get 6. Now to find the probability of red or black, you have to you have to add red and black together, and you'll get 12. And put that over the total number of balls of yarn, which is 24. When this is simplified down, you will get a total of 1/2. A 6-sided die is thrown 3 times. What is the probability that on all 3 rows a prime number will never come up? So the first step to solving this problem is finding what are the 3 not prime numbers from 1 to 6. And those numbers are 1, 4, and 6. So the probability of these numbers is 3 over 6, which is simplified down to 1/2. But since you're rolling the dice 3 times, you have to multiply this by itself 3 times. So you'll get 1/2 times 1/2 times 1/2, which when multiplied is equal to 1/8. So the probability that on all 3 rows a prime number will never come up is 1/8. A coin is tossed 3 times. What is the probability that 3 tails in a row will not show up? So the first step to solving this problem is listing out the number of possibilities. So for that, first would be tails, 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 head, tails, 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 head, and tails, head, head. Then we're going to do it for heads. So it'd be head, 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 tails, head, tails, head, and head, tails, tails. So now that we've listed out all the possibilities, we have to eliminate the 3 tails in a row because we don't want it to show up. So when we eliminate it, we have 7 possibilities left. So we would write 7 over the total number of possibilities, which including the 3 tails would be 8. So the possibility that 3 tails will not show up is 7/8.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!